Hi, now an example for proportional odds model. So proportional odds model, okay, so at first the data. So data, that we use the same data as the previous one, the 7.1. So this is the National Election Survey in 1996. So we have several variables. The party is the response variable Y. We have 3 levels. Original, we have 7 levels, but we make it the Democrat and the Independent and the Republican. Then income variable, and the other 3 variables are the predictor variables, so x1, x2, x3. So income is actually the categorical variable, but it's almost numeric, so we make it just numeric. So this is numeric variable. So educational level, so we have actually ordered variable, but we just make it as category. And we have the 7 levels. And the age. Age is just numeric variable. And later that we will also make education as the numeric variable because it's ordered from middle school graduate to graduate degree. So in short, the Y is the ordered variable and others are numeric variable. And then the MASS package, the library mass include the POLR function. So this is for the proportional, the odds model. And the format is similar to the usual multinomial regression. So the party is ordered variable. So the ordered variable that should be defined in R, but this data set already assigned the party as the ordered the categorical variable. Then we put the 3 variables as the predictor variables. Then we get the summary of this. So you can see that we have the 3 predictors. So we have 3 coefficients. Then also that we have intercept. So for example, so this compares the probability of the Democrat and the Independent. So the theta 1, so probability, so Democrat is 1 here, and the Independent is 2, and the Republican is 3. And we want to at first calculate the probability of the Y is less than or equal to 1. So that is Y is equal to 1. Then the logit function of this probability is equal to, at first, intercept. Yeah, so intercept is 0.4678, then minus these ones. So 0.003 times age plus 0.0299 times education as numeric variable plus 0.0126 times income variable. So this is this is what this output means. And the next one, the Independent and Republican, so the threshold is here. So that is the logit of probability of Y is equal to 2 or less is equal to this intercept 1.5513 minus the same thing. And you can see obviously this 1.55 is larger than 0.46. So always this probability is larger than this probability. Then we can calculate all the probabilities given the X values. And yeah, since this is still a kind of the multinomial, the regression model, so we can calculate the likelihood function. So residual deviance, that is -2 times likelihood function. log likelihood function, and also we can calculate AIC. AIC is that this likelihood function plus 2 times parameter. We have 3 parameters plus 2 parameters, so we have in total 5 parameters. So we can say the AIC is 10, larger than deviance. And we can also do model selection. So we can use the step function. Then actually the only income remains. And this is very significant. So now that you can get the function. So we have simpler function, the logic of probability of y is less than or equal to 1. So that is y is Democrat. This is 0.209 minus 0.0132 1312 times the income. Income is in $1,000. And y is less than or equal to 2. That is either Democrat or independent. Then this number becomes 1.29. Then again, the beta part is the same. So this is the model indicated by this output. So we can do the several, okay, so at first the testing. So we dropped 2 variables, age and the education level. So we dropped, and probably it's not significant because the stepwise regression choose that. Then actually, if we calculate the deviance of 2 models, POMB is a smaller model. It's probably the best model. And actually, it increases only by 1.06, even though we saved 2 parameters. So difference in degrees of freedom is 2, and improvement in likelihood, the deviance is equal to only 1.06. So it does not reject the null hypothesis, and we choose the smaller model. Larger model isn't significantly better than the larger model. Sorry, the larger model is not significantly better than small model. Yep, so this is some R example to calculate probability. So probability of Democrat, so that is y is equal to 1, or y is less than or equal to 1. If income is 0, we only keep the intercept. So this is the probability. So logit of this probability of y is less than or equal to 1 is equal to 0.209. So we multiply inverse logit function to get the number 0.552. So that means that if income is 0, probability that a person choose the person is the Democrat is 55%. And probability of y is less than or equal to 2, that is Democrat or independent. So that is obtained by this one, because the coefficient for the y is less than or equal to 2 is 1.29. And again, that we assume income is equal to 0. Then that is 78.4%. So difference between these two numbers is the probability of independent. Y is equal to 2. So that probability is 0.23. And so Republican, probability of Republican is 1 minus Democrat, 0.552 minus this one. So probably 0.22 or something. So I don't calculate it exactly, but you can get it. So second case is when income is $100,000. So we multiply 100, and just be careful that we have to put negative sign because that is the model. Estimated coefficient is positive 0.01312. So we have to subtract that times x minus beta x. So we can get this as the 25%. So that means if they $1,000, then the probability to be Democrat is only 25%, and independent 50%, and Republican 25% approximately. So that is the way to calculate the fitted probability. And a given data set, we can calculate the fitted value by, then that gives this. And actually the first 3 lines, income level is 1.5. So it's similar to the first result here. And the last line is the income equal to 115,000. So actually the last line of this fitted POMB is close to these probabilities.